Listening practice business statistics introduction. In today's data-driven world, the ability to analyze information, draw meaningful insights, and make informed decisions is a critical skill for business professionals. Whether you are a manager, entrepreneur, researcher, or student, understanding business statistics and research methodology is essential for navigating the complexities of modern business environments. Mastering Business Statistics and Research Methodology, a step-by-step guide to data-driven decision-making is designed to equip you with the knowledge, tools, and techniques needed to harness the power of data and research effectively. This book is structured to take you on a journey from foundational concepts to advanced statistical techniques, providing a comprehensive understanding of how to collect, analyze, and interpret data in a business context. Each chapter is carefully crafted to build on the previous one, ensuring a logical progression of learning. From understanding the basics of data and probability to mastering advanced methods like regression analysis and time series forecasting, this book covers it all. Additionally, it delves into the intricacies of research methodology, offering practical guidance on designing studies, collecting data, and presenting findings. What sets this book apart is its emphasis on real-world applications. Through case studies, examples, and hands-on exercises, you will see how statistical and research methods are applied in actual business scenarios. Whether you are analyzing market trends, optimizing operations, or evaluating the effectiveness of a marketing campaign, this book provides the tools and frameworks to help you succeed. By the end of this book, you will not only have a solid grasp of business statistics and research methodology but also the confidence to apply these skills in your professional or academic endeavors. Let this book be your guide to mastering data-driven decision-making and unlocking new opportunities for growth and innovation. Part 1, Introduction to Business Statistics and Research. 1. Business statistics is a critical tool for analyzing data, making informed decisions, and solving problems in the business world. This chapter introduces the fundamentals of business statistics, its importance, key concepts, and its role in decision-making. Chapter 1, What is business statistics? Business statistics involves the application of statistical methods to analyze data and solve business problems. It helps organizations make data-driven decisions, improve efficiency, and achieve their goals. 1. Definition and importance of business statistics. Definition: Business statistics is the science of collecting, organizing, analyzing, interpreting, and presenting data to support decision-making in business. Importance: Data-driven decisions enables businesses to base decisions on evidence rather than intuition. Performance measurement tracks key performance indicators, KPIs, to evaluate success. Risk management identifies and mitigates risks through data analysis. Market analysis understands customer behavior, market trends, and competition. Operational efficiency optimizes processes and resource allocation. 2. Key concepts in statistics: data, variables, distributions. Understanding basic statistical concepts is essential for analyzing and interpreting data. Data, definition: facts, figures, or information collected for analysis. Types: quantitative data, numerical data, e.g., sales figures, age. Qualitative data, categorical data, e.g., gender, product type. 2. Variables, definition: characteristics or attributes that can be measured or observed. Types: independent variable, the variable that is manipulated or changed, e.g., marketing budget. Dependent variable, the outcome that is measured, e.g., sales revenue. Discrete variable, takes specific, separate values, e.g., number of employees. Continuous variable, can take any value within a range, e.g., temperature. Distributions, definition: the way data is spread or distributed across values. Common distributions: normal distribution, a bell-shaped curve where data is symmetrically distributed around a mean. Binomial distribution, represents the number of successes in a fixed number of trials, e.g., coin flips. Poisson distribution, models the number of events occurring in a fixed interval, e.g., customer arrivals per hour. 3. The role of statistics in business decision-making. Statistics plays a vital role in helping businesses make informed, objective, and strategic decisions. Applications in business: market research, analyzing customer preferences and market trends to guide product development and marketing strategies. Quality control, monitoring production processes to ensure product quality and reduce defects. Financial analysis, evaluating financial performance, forecasting revenues, and managing budgets. Human resources, analyzing employee performance, turnover rates, and recruitment strategies. Risk assessment, identifying potential risks and developing mitigation strategies. Examples: a retail company uses sales data to identify the most profitable products and optimize inventory levels. A manufacturing firm employs statistical process control to reduce defects and improve efficiency. A financial institution uses regression analysis to predict loan default rates and manage credit risk. Conclusion 3. Business statistics is a powerful tool for transforming raw data into actionable insights. By understanding its definition, key concepts, and applications, businesses can make informed decisions, improve performance, and achieve their objectives. This chapter lays the foundation for exploring more advanced statistical methods and their role in business research and decision-making. Chapter 2, Overview of Research Methodology. Research methodology is the systematic process of collecting, analyzing, and interpreting data to answer specific questions or solve problems. In business, research is essential for making informed decisions, understanding market dynamics, and improving organizational performance. This chapter explores the definition and importance of business research, the types of research, and the steps involved in the research process. 1. Definition and importance of business research. Definition: business research is the process of gathering, analyzing, and interpreting data to address business problems, explore opportunities, and support decision-making. Importance: informed decision-making, provides evidence-based insights to guide strategic and operational decisions. Market understanding, helps businesses understand customer needs, preferences, and behaviors. Competitive advantage, identifies trends, opportunities, and threats in the market. Risk reduction, minimizes uncertainty by providing data-driven forecasts and analyses. Innovation, supports the development of new products, services, and processes. 2. Types of business research: qualitative, quantitative. Business research can be broadly categorized into qualitative and quantitative research, each with its own methods and applications. Qualitative research, definition, focuses on understanding concepts, opinions, or experiences through non-numerical data. Methods: 4. Interviews, one-on-one conversations to gather in-depth insights. Focus groups, group discussions to explore attitudes and perceptions. Case studies, detailed analysis of a specific organization, event, or individual. Observations, watching and recording behaviors in a natural setting. Applications, exploring customer motivations and preferences. Understanding organizational culture and employee experiences. Developing hypotheses for further research. Quantitative research, definition, involves the collection and analysis of numerical data to identify patterns, relationships, or trends. Methods: surveys, structured questionnaires to collect data from a large sample. Experiments, controlled studies to test cause and effect relationships. Secondary data analysis, using existing data sets, e.g., sales records, government statistics. Applications, measuring customer satisfaction and loyalty. Analyzing sales trends and forecasting demand. Testing the effectiveness of marketing campaigns. 3. The research process, from problem definition to reporting. The research process is a structured approach to conducting business research. It typically involves the following steps: 1. Define the research problem, identify the issue or opportunity to be addressed. Example, a company wants to understand why sales have declined in a specific region. 2. Conduct a literature review, review existing research and data related to the problem. Example, analyze industry reports and academic studies on sales trends. 3. Formulate research objectives and questions, define clear, specific goals and questions to guide the research. Example, what factors are contributing to the decline in sales in region X? 4. Choose a research design, select the appropriate research approach, qualitative, quantitative, or mixed methods. Example, use a survey to collect quantitative data on customer preferences. 5. Collect data, gather data using the chosen methods, e.g., surveys, interviews, experiments. Example, distribute a survey to 500 customers in the target region. 6. Analyze data, use statistical or qualitative analysis techniques to interpret the data. Example, perform regression analysis to identify factors influencing sales. 7. Interpret results, draw conclusions based on the data analysis. Example, identify that poor customer service is a key factor in declining sales. 8. Report findings, present the results in a clear and actionable format, e.g., reports, presentations. Example, prepare a report with recommendations to improve customer service. 9. Make recommendations and take action, use the research findings to inform decisions and implement changes. Example, train staff to improve customer service and monitor sales performance. Conclusion. Business research is a vital tool for understanding complex issues, exploring opportunities, and making data-driven decisions. By understanding the types of research and following a structured research process, businesses can gain valuable insights and achieve their goals. This chapter provides a foundation for conducting effective business research and highlights its importance in driving organizational success. Chapter 3, The Role of Data in Business. 6. Data is the foundation of informed decision-making in business. It provides insights into customer behavior, market trends, operational efficiency, and financial performance. This chapter explores the types of data, methods for collecting data, and strategies for ensuring data quality and reliability. 1. Understanding data types: primary, secondary, qualitative, quantitative. Data can be categorized based on its source and nature. Understanding these types is essential for selecting the right data for analysis. Primary data, definition: data collected first-hand for a specific research purpose. Examples: surveys, interviews, experiments, observations. Advantages: tailored to the research question, up-to-date, and specific. Disadvantages: time-consuming and costly to collect. Secondary data, definition: data collected by someone else for a different purpose but used for new research. Examples: government reports, industry publications, company records. Advantages: cost-effective, readily available, and often comprehensive. Disadvantages: may not be fully relevant or up-to-date. Qualitative data, definition: non-numerical data that describes qualities, characteristics, or experiences. Examples: interview transcripts, focus group notes, case studies. Applications: exploring motivations, opinions, and behaviors. Quantitative data, definition: numerical data that can be measured and analyzed statistically. Examples: sales figures, customer satisfaction ratings, website traffic. Applications: measuring performance, identifying trends, and testing hypotheses. 2. Data collection methods: surveys, interviews, observations. Choosing the right data collection method is crucial for obtaining accurate and relevant data. 7. Surveys, definition: structured questionnaires designed to collect data from a large sample. Types: online surveys, phone surveys, paper surveys. Advantages: efficient, scalable, and easy to analyze. Challenges: low response rates, potential for biased answers. Example: a retail company uses an online survey to measure customer satisfaction. Interviews: definition: one-on-one or group conversations to gather in-depth insights. Types: structured, fixed questions, semi-structured, flexible questions, unstructured, open-ended. Advantages: detailed and nuanced data. Challenges: time-consuming and requires skilled interviewers. Example: a marketing team conducts interviews to understand customer preferences for a new product. Observations: definition: watching and recording behaviors or events in a natural setting. Types: participant observation, researcher is involved; non-participant observation, researcher is detached. Advantages: provides real-world context and minimizes response bias. Challenges: observer bias and time-intensive. Example: a store manager observes customer behavior to optimize store layout. Experiments: definition: controlled studies to test cause and effect relationships. Types: lab experiments, field experiments. Advantages: high internal validity, clear conclusions. Challenges: may lack real-world applicability, external validity. Example: a company tests two different pricing strategies to determine which generates higher sales. Secondary data analysis, definition: using existing data sets for new research. Sources: government databases, industry reports, academic studies. Advantages: cost-effective and time-saving. Challenges: may not fully align with research objectives. Example: a financial analyst uses historical stock market data to predict future trends. 8.3. Ensuring data quality and reliability. High-quality data is accurate, reliable, and relevant. Poor data quality can lead to incorrect conclusions and flawed decisions. Key dimensions of data quality: accuracy, data is free from errors and reflects the true values. Completeness, all required data is collected without missing values. Consistency, data is uniform across sources and time periods. Timeliness, data is up-to-date and available when needed. Relevance, data is appropriate for the research question or decision. Strategies for ensuring data quality: 1. Define clear objectives, ensure data collection aligns with research goals. 2. Use reliable sources, collect data from credible and reputable sources. 3. Standardize data collection, use consistent methods and tools to minimize errors. 4. Train data collectors, ensure staff are skilled in data collection techniques. 5. Validate data, check for errors, outliers, and inconsistencies during and after collection. 6. Maintain data security, protect data from unauthorized access or loss. Tools for data quality management: data cleaning software, tools like Excel, OpenRefine, or Python libraries, e.g., Pandas, for identifying and correcting errors. Data validation tools, software that checks data for accuracy and completeness, e.g., Tailend, Informatica. Data governance frameworks, policies and procedures to ensure data quality and security. Conclusion: data is a critical asset for businesses, enabling informed decision-making and strategic planning. By understanding the types of data, selecting appropriate collection methods, and ensuring data quality and reliability, organizations can leverage data to gain valuable insights and achieve their goals. This chapter provides a foundation for effective data management and highlights its importance in driving business success. Part 2: Foundations of Business Statistics. 9. Descriptive statistics is a branch of statistics that focuses on summarizing and presenting data in a meaningful way. It helps businesses understand the basic features of their data, identify patterns, and make informed decisions. This chapter covers measures of central tendency, measures of dispersion, and data visualization techniques. Chapter 4: Descriptive statistics. Descriptive statistics provides tools to summarize and describe the main features of a data set. It is the first step in data analysis and is essential for understanding the characteristics of the data before applying more advanced techniques. 1. Measures of central tendency, mean, median, mode. Measures of central tendency describe the center or typical value of a data set. They provide a single value that represents the entire data set. Mean, definition, the average of all data points, calculated by summing the values and dividing by the number of observations. Formula, \\text mean equals \frac \sum underscore I equals 1 n x underscore I n \. Example, for the dataset 10, 20, 30, 40, 50, the mean is \frac 10 plus 20 plus 30 plus 40 plus 55 equals 30 \. Use case, useful for datasets with no extreme outliers. Median, definition, the middle value in a dataset when the values are arranged in ascending or descending order. Calculation, if the dataset has an odd number of observations, the median is the middle value. If the dataset has an even number of observations, the median is the average of the two middle values. Example, for the dataset 10, 20, 30, 40, 50, the median is 30. For 10, 20, 30, 40, the median is \frac 20 plus 32 equals 25 \. Use case, useful for datasets with outliers or skewed distributions. Mode, 10, definition, the value that appears most frequently in a dataset. Example, for the dataset 10, 20, 20, 30, 40, the mode is 20. Use case, useful for categorical data or identifying the most common value. 2. Measures of dispersion, range, variance, standard deviation. Measures of dispersion describe how spread out the data points are in a dataset. They provide insights into the variability of the data. Range, definition, the difference between the maximum and minimum values in a dataset. Formula, \text range equals \text maximum value, \text minimum value \. Example, for the dataset 10, 20, 30, 40, 50, the range is \50 to 10 equals 40 \. Use case, provides a quick sense of data spread but is sensitive to outliers. Variance, definition, the average of the squared differences from the mean. It measures how far each data point is from the mean. Formula, \text variance equals \frac \sum underscore I equals 1 n, x underscore I, \text mean, 2 n \. Example, for the dataset 10, 20, 30, 40, 50, the variance is \frac 10 to 30, 2 plus, 20 to 30, 2 plus, 30 to 30, 2 plus, 40 30, 2 plus, 50 to 30, 25 equals 200 \. Use case * useful for understanding data variability but is in squared units. Standard deviation, definition, the square root of the variance. It measures the average distance of data points from the mean in the same units as the data. Formula, \text standard deviation equals \sqrt text variance \11. Example, for the dataset 10, 20, 30, 40, 50, the standard deviation is \sqrt 200 approximate 14.14 \. Use case, provides a clear measure of data spread and is widely used in statistical analysis. 3. Data visualization techniques, charts, graphs, histograms. Data visualization is the graphical representation of data to help identify patterns, trends, and outliers. Bar charts, use case, compare categorical data or show frequency distributions. Example, a bar chart showing sales by product category. Line graphs, use case, display trends over time. Example, a line graph showing monthly sales over a year. Pie charts, use case, show proportions or percentages of a whole. Example, a pie chart showing market share by company. Histograms, use case, display the distribution of numerical data. Example, a histogram showing the distribution of customer ages. Scatter plots, use case, show relationships between two numerical variables. Example, a scatter plot showing the relationship between advertising spend and sales. Box plots, use case, summarize data distribution and identify outliers. Example, a box plot showing the distribution of employee salaries across departments. Conclusion. Descriptive statistics is a powerful tool for summarizing and understanding data. By using measures of central tendency, measures of dispersion, and data visualization techniques, businesses can gain valuable insights into their 12 data and make informed decisions. This chapter provides the foundational knowledge needed to analyze and present data effectively, setting the stage for more advanced statistical methods. Chapter 5, Probability and Distributions. Probability is the foundation of statistical analysis and decision-making in business. It helps quantify uncertainty and predict outcomes, enabling businesses to make informed decisions under risk. This chapter introduces basic probability concepts, common probability distributions, and their applications in business. 1. Basic probability concepts. Probability measures the likelihood of an event occurring. It ranges from 0, impossible, to 1, certain, and is expressed as a fraction, decimal, or percentage. Key definitions: experiment, a process that produces outcomes, e.g., rolling a die. Outcome, a possible result of an experiment, e.g., rolling a 3. Event, a set of outcomes, e.g., rolling an even number. Sample space, the set of all possible outcomes, e.g., 1, 2, 3, 4, 5, 6 for a die roll. Probability rules. Rule of complement, the probability of an event not occurring is \1, p, \text event, \. Addition rule, for two mutually exclusive events, \p, a \text or b, equals p, a, plus p, b, \. Multiplication rule, for two independent events, \p, a \text and b, equals p, a, times p, b, \. Example, in a deck of 52 cards, the probability of drawing a heart is frac 1352 equals 0.25 25%. 2. Common probability distributions, normal, binomial, Poisson. Probability distributions describe how probabilities are distributed over the values of a random variable. 3 common distributions are: 13, normal distribution, Gaussian distribution, description, a bell-shaped, symmetric distribution where most data points cluster around a mean. Parameters, mean, \, mu \, and standard deviation, \, sigma \. Formula, \f, x, equals frac 1 sigma sqrt2 pi e dash frac, x, mu, 2 sigma 2 applications, modeling heights, weights, or test scores. Quality control in manufacturing. Example, the distribution of employee salaries in a large company. Binomial distribution, description, models the number of successes in a fixed number of independent trials, each with the same probability of success. Parameters, number of trials, \n \, and probability of success, p \. Formula, \p, x equals k, equals \binom nkpk, 1, p, n, k where binom nk is the binomial coefficient. Applications, predicting the number of defective items in a batch. Estimating the likelihood of a certain number of sales from a marketing campaign. Example, the probability of getting exactly 3 heads in 5 coin flips. Poisson distribution, description, models the number of events occurring in a fixed interval of time or space, given a constant average rate. Parameters, average rate, backslash, lambda . Formula, \p, x equals k, equals frac lambda k e lambda k. Applications, counting the number of customer arrivals at a store in an hour. Modeling the number of defects in a production process. 14, example, the probability of receiving 5 customer calls in an hour if the average rate is 3 calls per hour. 3. Applications of probability in business. Probability is widely used in business to analyze risks, make predictions, and optimize decisions. Risk management, assessing the likelihood of adverse events, e.g., market crashes, supply chain disruptions. Example, an insurance company uses probability to calculate premiums based on risk. Quality control, monitoring production processes to ensure product quality. Example, a manufacturer uses the normal distribution to set acceptable quality limits. Financial analysis, predicting stock prices, interest rates, or loan defaults. Example, a bank uses probability to assess the risk of loan defaults. Marketing and sales, estimating customer behavior and sales trends. Example, a retailer uses the binomial distribution to predict the success of a promotional campaign. Operations management, optimizing inventory levels and resource allocation. Example, a logistics company uses the Poisson distribution to model delivery times. Conclusion. Probability and probability distributions are essential tools for understanding uncertainty and making data-driven decisions in business. By mastering basic probability concepts and common distributions, businesses can analyze risks, predict outcomes, and optimize processes. This chapter provides the foundational knowledge needed to apply probability in real-world business scenarios. 15. Chapter 6, Inferential Statistics. Inferential statistics allows us to make conclusions about a population based on sample data. It is a powerful tool for decision-making, enabling businesses to generalize findings, test hypotheses, and estimate population parameters. This chapter covers sampling methods, hypothesis testing, and confidence intervals. 1. Sampling methods and sampling distributions. Sampling is the process of selecting a subset of individuals from a population to estimate characteristics of the entire population. Sampling methods, simple random sampling, every individual in the population has an equal chance of being selected. Example, drawing names from a hat to select survey participants. Stratified sampling, the population is divided into subgroups, strata, and samples are randomly selected from each stratum. Example, surveying equal numbers of men and women to ensure gender representation. Cluster sampling, the population is divided into clusters, and entire clusters are randomly selected. Example, selecting specific schools in a district for a study. Systematic sampling, selecting every th individual from a list. Example, surveying every 10th customer entering a store. Sampling distributions, definition, the distribution of a statistic, e.g., mean, proportion, calculated from multiple samples of the same size. Central limit theorem, CLT states that the sampling distribution of the mean will be approximately normal, regardless of the population distribution, if the sample size is large enough, and \30 . Example, if we repeatedly sample 50 employees and calculate their average salary, the distribution of these averages will be approximately normal. 2. Hypothesis testing, null and alternative hypotheses, p-values. Hypothesis testing is a statistical method used to make decisions about a population based on sample data. Steps in hypothesis testing, 16.1. State the hypotheses, null hypothesis, \h_0 the default assumption, e.g., no effect or no difference, alternative hypothesis, \h_1 the claim we want to test, e.g., there is an effect or difference, example, \h_0 the new drug has no effect. \h_1 the new drug is effective. To choose a significance level, \alpha the probability of rejecting \h_0 when it is true, commonly alpha equals 0.05 3. Calculate the test statistic, a value computed from the sample data, e.g., t-statistic, z-statistic. 4. Determine the p-value, the probability of observing the test statistic or something more extreme, assuming \h_0 is true. 5. Make a decision, if p \lek alpha reject \h_0 if p alpha fail to reject \h_0 Example, a company tests whether a new marketing campaign increases sales. \h_0 sales remain unchanged. \h_1 sales increase. If the p-value is 0.03, \0.05 reject \h_0 and conclude the campaign is effective. 3. Confidence intervals and margin of error. Confidence intervals provide a range of values within which a population parameter is likely to lie, along with a level of confidence. Confidence interval formula, text ci equals text sample statistic PM, text critical value times text standard error, critical value, depends on the confidence level, e.g., 1.96 for 95% confidence. Standard error, measures the variability of the sample statistic. Margin of error, the range above and below the sample statistic in a confidence interval. Formula, text margin of error equals text critical value times text standard error 17 Example, a survey finds that 60% of customers prefer product A, with a margin of error of 4% at a 95% confidence level. The 95% confidence interval is \60% PM4 %, or \56% 64 %. Interpretation, we are 95% confident that the true proportion of customers who prefer product A lies between 56% and 64%. Applications of inferential statistics in business, market research, estimating customer preferences and behaviors. Example, a company uses confidence intervals to estimate the percentage of customers likely to buy a new product. Quality control, testing whether a production process meets specifications. Example, a manufacturer uses hypothesis testing to determine if a new process reduces defects. Financial analysis, estimating returns or risks of investments. Example, an analyst uses confidence intervals to predict future stock prices. Human resources, evaluating the effectiveness of training programs. Example, a company uses hypothesis testing to assess whether a training program improves employee performance. Conclusion: inferential statistics is a powerful tool for making data-driven decisions in business. By understanding sampling methods, hypothesis testing, and confidence intervals, businesses can draw meaningful conclusions from sample data and apply them to broader populations. This chapter provides the foundational knowledge needed to analyze data, test hypotheses, and make informed decisions in real-world business scenarios. Part 3, Advanced statistical techniques. 18 Correlation and regression analysis are powerful statistical tools used to explore relationships between variables and make predictions. This chapter delves into the concepts of correlation and causation, simple and multiple linear regression, and their applications in business forecasting. Chapter 7, Correlation and Regression Analysis. Correlation and regression analysis help businesses understand relationships between variables and predict outcomes. These techniques are widely used in areas such as marketing, finance, and operations management. 1. Understanding correlation and causation. Correlation measures the strength and direction of the linear relationship between two variables. Correlation coefficient, R ranges from -1 to 1. R equals 1 perfect positive correlation. R equals -1 perfect negative correlation. R equals 0 no correlation. Example *A correlation of 0.8 between advertising spend and sales indicates a strong positive relationship. Causation implies that one variable directly affects another. Important note, correlation does not imply causation. Additional evidence is needed to establish a causal relationship. Example, ice cream sales and drowning incidents may be correlated, both increase in summer, but one does not cause the other. 2. Simple and multiple linear regression. Regression analysis models the relationship between a dependent variable and one or more independent variables. Simple linear regression models the relationship between one independent variable, x, and one dependent variable, y. Equation 19 \y equals \beta_0 plus \beta_1x plus \epsilon \beta_0 intercept value of y when x equals 0 \beta_1 slope change in y for a 1 unit change in x epsilon error term accounts for variability not explained by x. Example * predicting sales y based on advertising spend x. Multiple linear regression models the relationship between multiple independent variables x_1 x_2 and one dependent variable y. Equation y equals \beta_0 plus \beta_1x_1 plus \beta_2x_2 plus \beta_kx_k plus epsilon example * predicting house prices y based on size x_1 location x_2 and age x_3 Key metrics in regression R² R2 measures the proportion of variance in y explained by x p-value tests the significance of each independent variable. Residuals differences between observed and predicted values. 3. Applications of regression in business forecasting. Regression analysis is widely used in business to make predictions and inform decision-making. Sales forecasting predict future sales based on factors like advertising spend, seasonality, and economic conditions. Example, a retailer uses regression to forecast holiday sales based on historical data. Demand prediction estimate demand for products or services to optimize inventory and production. Example, a manufacturer uses regression to predict demand for a new product based on market trends. Financial analysis predict stock prices, interest rates, or credit risk. 20. Example, a bank uses regression to assess the likelihood of loan defaults based on customer data. Marketing effectiveness, measure the impact of marketing campaigns on sales or customer engagement. Example, a company uses regression to analyze the relationship between social media ads and website traffic. Operational efficiency, optimize processes by identifying key drivers of performance. Example, a logistics company uses regression to predict delivery times based on traffic and weather conditions. Conclusion: correlation and regression analysis are essential tools for understanding relationships between variables and making data-driven predictions in business. By mastering these techniques, businesses can improve forecasting accuracy, optimize operations, and make informed decisions. This chapter provides the foundational knowledge needed to apply correlation and regression analysis in real-world business scenarios. Chapter 8: Time Series Analysis. Time series analysis is a statistical technique used to analyze data points collected or recorded over time. It helps businesses identify trends, seasonal patterns, and other time-dependent behaviors, enabling better forecasting and decision-making. This chapter explores the fundamentals of time series data, key analysis techniques, and their applications in business. 1. Understanding time series data. Time series data consists of observations recorded at regular intervals over time. It is widely used in business to analyze trends and make predictions. Characteristics of time series data: trend, a long-term increase or decrease in the data, e.g., rising sales over several years. Seasonality, regular patterns that repeat at fixed intervals, e.g., higher sales during holidays. Cyclical patterns, fluctuations that occur over longer periods, often influenced by economic cycles. 21. Random noise, irregular variations that cannot be explained by trend, seasonality, or cycles. Examples of time series data: monthly sales data, daily stock prices, quarterly GDP growth. 2. Techniques for time series analysis. Several techniques are used to analyze and forecast time series data. Two common methods are moving averages and exponential smoothing. Moving averages, definition: a technique that smooths out short-term fluctuations by calculating the average of data points over a fixed period. Types: simple moving average, SMA, average of the last n data points. Text SMA equals frac x_t plus x_t1 plus dots plus x_tn plus 1 n weighted moving average, WMA, assigns different weights to data points, giving more importance to recent observations. Use case: identifying trends by removing noise from data. Example: a 3-month moving average of sales data to identify underlying trends. Exponential smoothing, definition: a technique that assigns exponentially decreasing weights to past observations, giving more importance to recent data. Formula: \s_t equals \alpha x_t plus 1 \alpha s_t1 \s_t smoothed value at time \t x_t actual value at time t alpha smoothing factor 0 alpha 1 Use case: forecasting future values based on recent trends. 22. Example: using exponential smoothing to predict next month's sales based on historical data. Advanced techniques: ARIMA, autoregressive integrated moving average, a more sophisticated model that combines autoregression, differencing, and moving averages. Seasonal decomposition, separates a time series into trend, seasonal, and residual components. 3. Applications in business. Trend analysis. Time series analysis is widely used in business to analyze trends, forecast future performance, and inform decision-making. Sales forecasting, predict future sales based on historical data, accounting for trends and seasonality. Example, a retailer uses time series analysis to forecast holiday sales and plan inventory. Financial analysis, analyze stock prices, interest rates, or currency exchange rates to identify trends and make investment decisions. Example, a financial analyst uses time series analysis to predict future stock prices. Demand planning, estimate future demand for products or services to optimize production and supply chain management. Example, a manufacturer uses time series analysis to predict demand for a new product. Operational efficiency, monitor and optimize key performance indicators, KPIs, over time. Example, a logistics company uses time series analysis to track delivery times and identify inefficiencies. Marketing effectiveness, analyze the impact of marketing campaigns over time and adjust strategies accordingly. Example, a company uses time series analysis to measure the long-term impact of a social media campaign. Conclusion 23 Time series analysis is a powerful tool for understanding and predicting trends in business data. By applying techniques like moving averages and exponential smoothing, businesses can uncover patterns, make accurate forecasts, and improve decision-making. This chapter provides the foundational knowledge needed to analyze time series data and apply it effectively in real-world business scenarios. Chapter 9, Multivariate Analysis. Multivariate analysis involves examining multiple variables simultaneously to understand their relationships and patterns. It is a powerful tool for uncovering hidden structures in data and making informed business decisions. This chapter explores factor analysis, principal component analysis, PCA, cluster analysis, and their applications in market research and customer segmentation. 1. Factor analysis and principal component analysis, PCA. These techniques are used to reduce the dimensionality of data by identifying underlying factors or components. Factor analysis, definition, a statistical method used to identify latent variables, factors, that explain the correlations among observed variables. Use case, simplifying complex data sets by grouping related variables into factors. Example, in market research, factor analysis can group survey questions into factors like customer satisfaction or brand loyalty. Principal component analysis, PCA, definition, a technique that transforms a large set of variables into a smaller set of uncorrelated components, ordered by the amount of variance they explain. Steps: 1. Standardize the data. 2. Compute the covariance matrix. 3. Calculate eigenvectors and eigenvalues. 4. Select the top components that explain the most variance. Use case: reducing dimensionality while retaining as much information as possible. Example, PCA can be used to reduce the number of variables in a customer data set, e.g., age, income, spending habits, into a few principal components for easier analysis. 24-2. Cluster analysis and segmentation. Cluster analysis groups similar data points into clusters, enabling businesses to identify patterns and segments. Cluster analysis, definition, a technique that groups data points into clusters based on their similarity. Common methods: k-means clustering, divides data into \k clusters by minimizing the distance between points and cluster centers. Hierarchical clustering, builds a tree-like structure of clusters, allowing for flexible grouping. Use case: identifying natural groupings in data. Example, grouping customers based on purchasing behavior for targeted marketing. Segmentation, definition, dividing a market or customer base into distinct groups with similar characteristics. Types of segmentation: demographic, age, gender, income. Geographic, location, region. Psychographic, lifestyle, values. Behavioral, purchasing habits, brand loyalty. Use case: tailoring products, services, and marketing strategies to specific customer groups. Example, a retail company segments its customers into frequent buyers, discount seekers, and occasional shoppers. 3. Applications in market research and customer segmentation. Multivariate analysis is widely used in market research and customer segmentation to gain insights and drive business strategies. Market research, identifying customer preferences. Factor analysis can uncover underlying factors influencing customer preferences. Example, a car manufacturer uses factor analysis to identify key factors, e.g., safety, fuel efficiency, that influence customer buying decisions. 25. Customer segmentation, targeted marketing. Cluster analysis helps businesses create personalized marketing campaigns for different customer segments. Example, an e-commerce platform uses clustering to group customers into segments like high spenders, bargain hunters, and new users. Product development, understanding customer needs. Multivariate analysis helps identify customer needs and preferences for product development. Example, a tech company uses PCA to analyze customer feedback and prioritize features for a new smartphone. Competitive analysis, benchmarking performance. Cluster analysis can group competitors based on market performance, helping businesses identify strengths and weaknesses. Example, a beverage company clusters competitors based on market share, pricing, and customer satisfaction to refine its strategy. Conclusion. Multivariate analysis is a powerful tool for uncovering patterns and relationships in complex data sets. By applying techniques like factor analysis, PCA, and cluster analysis, businesses can gain valuable insights, improve decision-making, and tailor strategies to meet customer needs. This chapter provides the foundational knowledge needed to leverage multivariate analysis in market research and customer segmentation. Part 4. Research methodology. Designing business research is a critical step in ensuring that the research process is systematic, objective, and aligned with organizational goals. This chapter focuses on defining the research problem, formulating research questions and hypotheses, and selecting the appropriate research design. Chapter 10, Designing Business Research. 26. Effective research design ensures that the study addresses the right questions, uses appropriate methods, and produces reliable and valid results. This chapter covers the key steps in designing business research. 1. Defining the research problem and objectives. The first step in any research project is to clearly define the problem and establish the objectives. Research problem, a specific issue, gap, or opportunity that the research aims to address. Example, a company wants to understand why customer satisfaction has declined in the past year. Research objectives, clear, measurable goals that guide the research process. Example, identify factors contributing to declining customer satisfaction. Recommend strategies to improve customer satisfaction. Importance of a well-defined problem, ensures the research is focused and relevant. Provides a clear direction for data collection and analysis. 2. Formulating research questions and hypotheses. Research questions and hypotheses guide the investigation and provide a framework for analysis. Research questions, broad questions that the research seeks to answer. Example, what factors are influencing customer satisfaction? How do pricing strategies affect sales performance? Hypotheses, testable statements that predict the relationship between variables. Null hypothesis, \h_0 assumes no relationship or effect. Alternative hypothesis, \h_1 assumes a relationship or effect. 27, example, \h_0 there is no relationship between customer service quality and customer satisfaction. \h_1 higher customer service quality leads to higher customer satisfaction. Importance of clear research questions and hypotheses, provides a clear focus for the study. Guides the selection of research methods and data analysis techniques. 3. Choosing the right research design, exploratory, descriptive, causal, the research design defines the overall approach for addressing the research problem. The three main types of research designs are exploratory, descriptive, and causal. Exploratory research, purpose, to explore a problem or phenomenon when little is known about it. Methods, literature reviews, interviews, focus groups, case studies. Use case, generating hypotheses or identifying key variables. Example, a company explores customer perceptions of a new product concept through focus groups. Descriptive research, purpose, to describe characteristics, behaviors, or trends. Methods, surveys, observational studies, secondary data analysis. Use case, providing a detailed snapshot of a situation. Example, a retailer conducts a survey to describe customer demographics and shopping habits. Causal research, purpose, to determine cause and effect relationships between variables. Methods, experiments, quasi-experiments. Use case, testing hypotheses or evaluating the impact of interventions. Example, a company tests the effect of a new advertising campaign on sales using a controlled experiment. Choosing the right design, exploratory, use when the research problem is unclear or understudied. Descriptive, use when the goal is to describe or measure phenomena. Causal, use when the goal is to establish cause and effect relationships. 28 Conclusion. Designing business research is a systematic process that involves defining the research problem, formulating research questions and hypotheses, and selecting the appropriate research design. By following these steps, businesses can ensure that their research is focused, methodologically sound, and aligned with organizational objectives. This chapter provides the foundational knowledge needed to design effective business research studies. Chapter 11, Data Collection Methods. Data collection is a critical step in the research process, as the quality of data directly impacts the validity and reliability of the findings. This chapter explores various data collection methods, including surveys, interviews, focus groups, observational studies, and experiments. 1. Surveys and questionnaires, design, sampling, administration. Surveys and questionnaires are widely used to collect quantitative data from a large sample of respondents. Designing surveys, question types, closed-ended questions. Respondents choose from predefined options, e.g., multiple choice, Likert scale. Open-ended questions. Respondents provide free text answers. Best practices. Keep questions clear, concise, and unbiased. Use a logical flow and group related questions together. Pilot test the survey to identify and fix issues. Sampling methods. Probability sampling. Every individual in the population has a known chance of being selected, e.g., simple random sampling, stratified sampling. Non-probability sampling. Individuals are selected based on convenience or judgment, e.g., convenience sampling, snowball sampling. 29. Administration methods. Online surveys, cost-effective and easy to distribute, e.g., Google Forms, SurveyMonkey. Phone surveys, allow for direct interaction but can be time-consuming. Mail surveys, reach a wide audience but may have low response rates. In-person surveys, provide high response rates but are labor-intensive. Example, a company uses an online survey to collect customer feedback on a new product. 2. Interviews and focus groups. Interviews and focus groups are qualitative methods used to gather in-depth insights from respondents. Interviews, types, structured interviews, follow a fixed set of questions. Semi-structured interviews, combine fixed questions with flexibility to explore topics in depth. Unstructured interviews, open-ended and conversational. Advantages, provide detailed and nuanced data. Challenges, time-consuming and require skilled interviewers. Example, a researcher conducts semi-structured interviews with employees to understand workplace satisfaction. Focus groups. Definition, a group discussion led by a moderator to explore attitudes, perceptions, and opinions. Advantages: generate rich, interactive data and uncover group dynamics. Challenges: may be influenced by dominant participants or groupthink. Example: a marketing team uses focus groups to test consumer reactions to a new advertising campaign. 3. Observational and experimental methods. Observational and experimental methods are used to study behavior and test cause and effect relationships. Observational methods: definition, watching and recording behavior in a natural or controlled setting. Types: participant observation, the researcher is involved in the setting being studied. 30. Non-participant observation, the researcher observes without interacting. Advantages: provides real-world context and minimizes response bias. Challenges: observer bias and difficulty in generalizing findings. Example: a retail store observes customer behavior to optimize store layout. Experimental methods: definition, controlled studies to test cause and effect relationships by manipulating one or more variables. Key components: independent variable, the variable being manipulated. Dependent variable, the outcome being measured. Control group, a group that does not receive the intervention. Experimental group, a group that receives the intervention. Advantages: high internal validity and clear conclusions. Challenges: may lack real-world applicability, external validity. Example: a company tests the effectiveness of two pricing strategies by randomly assigning customers to different groups. Conclusion: choosing the right data collection method is essential for obtaining accurate and meaningful results. Surveys, interviews, focus groups, observational studies, and experiments each have unique strengths and limitations, making them suitable for different research objectives. This chapter provides the foundational knowledge needed to select and implement appropriate data collection methods in business research. Chapter 12: Data Analysis and Interpretation. Data analysis and interpretation are critical steps in the research process, transforming raw data into meaningful insights. This chapter explores methods for analyzing qualitative and quantitative data, as well as strategies for interpreting and presenting research findings effectively. 1. Qualitative data analysis, coding, thematic analysis. Qualitative data analysis involves interpreting non-numerical data to identify patterns, themes, and insights. 31. Coding, definition, the process of labeling and organizing qualitative data into categories or themes. Steps: 1. Open coding, identify initial concepts and categories in the data. 2. Axial coding, group related codes into broader categories. 3. Selective coding, identify core themes that connect all categories. Example: in a study on employee satisfaction, codes like work-life balance, career growth, and management support might emerge. Thematic analysis, definition, a method for identifying, analyzing, and reporting patterns, themes, within qualitative data. Steps: 1. Familiarize yourself with the data. 2. Generate initial codes. 3. Search for themes. 4. Review and refine themes. 5. Define and name themes. 6. Produce the final report. Example: a researcher identifies themes like job satisfaction, organizational culture, and compensation from interview transcripts. Software tools: NVivo, a tool for organizing and analyzing qualitative data. Atlas.ti, software for coding and thematic analysis. MACTA, a program for qualitative and mixed methods research. 2. Quantitative data analysis, statistical tests, software tools. Quantitative data analysis involves using statistical methods to analyze numerical data and test hypotheses. Descriptive statistics, summarize and describe the main features of a dataset. Examples: mean, median, mode, standard deviation, frequency distributions. Inferential statistics. 32. Make inferences about a population based on sample data. Common tests, t-tests, compare the means of two groups. ANOVA, compare the means of 3 or more groups. Chi-square test, test relationships between categorical variables. Regression analysis, examine relationships between dependent and independent variables. Software tools, Excel, basic data analysis and visualization. SPSS, a comprehensive tool for statistical analysis. R, a programming language for advanced statistical analysis. Python, a versatile language for data analysis and machine learning. Example, a researcher uses regression analysis to examine the relationship between advertising spend and sales revenue. 3. Interpreting and presenting research findings. Interpreting and presenting findings is the final step in the research process, where insights are communicated to stakeholders. Interpreting findings, contextualize results, relate findings to the research objectives and existing literature. Identify patterns, highlight key trends, relationships, or anomalies. Draw conclusions, summarize what the findings mean for the research problem. Consider limitations, acknowledge any constraints or biases in the study. Presenting findings, visualizations, use charts, graphs, and tables to make data more accessible. Bar charts, compare categories. Line graphs, show trends over time. Pie charts, display proportions. Scatter plots, show relationships between variables. Reports, structure the report with clear sections, e.g., introduction, methodology, results, discussion. Presentations, use slides to summarize key points and engage the audience. 33, example, a marketing team presents survey findings on customer preferences using bar charts and a summary report. Conclusion. Data analysis and interpretation are essential for transforming raw data into actionable insights. By applying qualitative and quantitative analysis techniques and presenting findings effectively, researchers can provide valuable information to support decision-making. This chapter provides the foundational knowledge needed to analyze, interpret, and communicate research findings in a clear and impactful way. Part 5, Practical Applications and Continuous Improvement. Case studies provide valuable insights into how businesses apply statistics and research to solve real-world problems. This chapter explores successful applications of statistics, lessons learned from research failures, and best practices from industry leaders. Chapter 13, Case Studies in Business Statistics and Research. Case studies highlight the practical use of statistics and research in business, offering lessons and inspiration for improving decision-making and problem-solving. 1. Successful applications of statistics in business. Statistics plays a crucial role in helping businesses make data-driven decisions and achieve their goals. Example 1, Netflix's recommendation system. Application: Netflix uses statistical algorithms to analyze user behavior and recommend personalized content. Outcome: improved customer satisfaction and retention. Example 2, Walmart's inventory management. Application: Walmart uses statistical models to optimize inventory levels and reduce stockouts. 34, Outcome: increased efficiency and reduced costs. Example 3, Procter & Gamble's product development. Application: P&G uses statistical analysis to test and refine new products before launch. Outcome: higher success rates for new products. 2. Lessons learned from research failures. Research failures provide valuable lessons on what to avoid and how to improve future studies. Example 1, New Coke, 1985, failure. Coca-Cola launched New Coke after taste tests showed it was preferred over the original formula. However, the launch failed due to a lack of understanding of brand loyalty. Lesson: research should consider emotional and cultural factors, not just quantitative data. Example 2, Target's data breach, 2013, failure. Target's failure to act on statistical warnings about a data breach led to a massive security incident. Lesson: businesses must prioritize data security and act on predictive analytics. Example 3, Blockbuster's decline, failure. Blockbuster failed to adapt to changing consumer preferences and the rise of streaming services, despite having access to market data. Lesson: businesses must use data to anticipate trends and innovate proactively. 3. Best practices from industry leaders. Industry leaders demonstrate how to effectively use statistics and research to drive success. Best practice 1, Amazon's data-driven culture approach. Amazon uses data to guide decisions at all levels, from pricing strategies to logistics. Outcome: dominance in e-commerce and customer satisfaction. Best practice 2, Google's A/B testing approach. Google conducts extensive A/B testing to optimize user experience and ad performance. Outcome: continuous improvement and innovation. 35. Best practice 3, Toyota's lean manufacturing approach. Toyota uses statistical process control to minimize waste and improve quality. Outcome: industry-leading efficiency and product reliability. Conclusion: case studies in business statistics and research provide valuable insights into successful applications, lessons from failures, and best practices from industry leaders. By learning from these examples, businesses can improve their use of data and research to make better decisions, innovate, and achieve long-term success. This chapter highlights the importance of applying statistics and research effectively in real-world business scenarios. Chapter 14, Continuous Learning and Improvement in the Fast-Evolving World of Business and Data Analytics. Continuous learning and improvement are essential for staying competitive and effective. This chapter focuses on staying updated with statistical methods and tools, building a data-driven culture, and developing a personal development plan. 1. Staying updated with statistical methods and tools. The field of statistics and data analysis is constantly evolving, with new methods, tools, and technologies emerging regularly. Strategies for staying updated: follow industry trends, regularly read industry publications, blogs, and research papers. Examples: Harvard Business Review, Journal of Business Research, Towards Data Science. Attend conferences and workshops, participate in events to learn about the latest developments and network with experts. Examples: Strata Data Conference, Predictive Analytics World, local meetups. Take online courses, enroll in courses to learn new tools and techniques. Platforms: Coursera, edX, Udemy, DataCamp. Join professional organizations, become a member of organizations like the American Statistical Association, ASA, or the Data Science Association. 36. Key tools to learn: programming languages, Python, R, SQL. Statistical software, SPSS, SAS, Stata. Data visualization tools, Tableau, Power BI, Matplotlib. Machine learning libraries, Scikit-learn, TensorFlow, PyTorch. 2. Building a data-driven culture. A data-driven culture empowers organizations to make decisions based on data and evidence rather than intuition or guesswork. Steps to build a data-driven culture: 1. Leadership commitment: ensure that leaders prioritize data-driven decision-making and lead by example. 2. Data literacy training: provide training to employees at all levels to improve their data skills. 3. Access to data: make data easily accessible to employees while ensuring data security and privacy. 4. Encourage experimentation: foster a culture where employees feel comfortable testing hypotheses and learning from data. 5. Celebrate successes: recognize and reward teams that use data effectively to achieve results. Example: a retail company trains its store managers to use data analytics tools to track sales performance and customer behavior, leading to improved decision-making and profitability. 3. Developing a personal development plan. A personal development plan helps individuals set goals, acquire new skills, and advance their careers in statistics and data analysis. Steps to create a personal development plan: 1. Assess current skills, identify your strengths and areas for improvement. 2. Set clear goals, define short-term and long-term career objectives. Example, learn Python for data analysis within 6 months or become a certified data scientist within 2 years. 3. Identify learning resources, choose courses, books, and mentors to help you achieve your goals. 4. Create a timeline, set deadlines for completing specific milestones. 5. Track progress, regularly review your progress and adjust your plan as needed. 37. Example plan, goal, improve data visualization skills. Actions, complete a Tableau certification course in 3 months. Create a portfolio of data visualization projects. Attend a data visualization workshop. Timeline, 6 months. Conclusion. Continuous learning and improvement are essential for staying relevant and effective in the field of business statistics and data analysis. By staying updated with statistical methods and tools, building a data-driven culture, and developing a personal development plan, individuals and organizations can enhance their skills, make better decisions, and achieve long-term success. This chapter provides a roadmap for fostering growth and innovation in a data-driven world. Chapter 15, Overcoming Challenges in Business Research. Business research often faces challenges related to data privacy, data quality, and research validity. Addressing these challenges is crucial for ensuring the integrity and usefulness of research findings. This chapter explores strategies for managing data privacy and ethical issues, dealing with incomplete or biased data, and ensuring the validity and reliability of research. 1. Managing data privacy and ethical issues. Data privacy and ethical considerations are critical in business research, especially with the increasing use of personal and sensitive data. Key principles: informed consent, ensure participants understand the purpose of the research and agree to participate voluntarily. Confidentiality, protect participants' identities and personal information. Transparency, clearly communicate how data will be collected, used, and stored. Compliance, adhere to legal and regulatory requirements, e.g., GDPR, HIPAA. 38. Strategies for managing privacy and ethics. Data anonymization, remove or encrypt personally identifiable information, PII, to protect privacy. Ethics review boards, submit research proposals to an ethics review board for approval. Data security, use secure methods for data storage and transmission, e.g., encryption, access controls. Ethical training, provide training to researchers on ethical guidelines and best practices. Example, a market research firm anonymizes survey responses and obtains consent from participants before collecting data. 2. Dealing with incomplete or biased data. Incomplete or biased data can undermine the validity of research findings. Addressing these issues is essential for producing reliable results. Causes of incomplete or biased data: non-response bias, participants who do not respond may differ from those who do. Sampling bias, the sample may not be representative of the population. Measurement bias, errors in data collection methods or tools. Missing data, data may be incomplete due to technical issues or participant errors. Strategies for addressing data issues: improve data collection, use clear and concise questions, follow up with non-respondents, and ensure a representative sample. Data imputation, use statistical methods to estimate missing values, e.g., mean imputation, regression imputation. Bias correction, apply techniques to adjust for known biases, e.g., weighting, stratification. Robust analysis, use statistical methods that are less sensitive to outliers or missing data, e.g., non-parametric tests. Example, a researcher uses multiple imputation to handle missing data in a customer satisfaction survey. 3. Ensuring the validity and reliability of research. Validity and reliability are key indicators of the quality and credibility of research findings. 39. Validity, definition, the extent to which a study measures what it claims to measure. Types of validity: internal validity, the degree to which the research design supports causal inferences. External validity, the extent to which findings can be generalized to other settings or populations. Construct validity, the degree to which a test measures the theoretical construct it is intended to measure. Strategies for ensuring validity, use well-established measurement tools and methods. Control for confounding variables in experimental designs. Conduct pilot studies to test research instruments. Reliability, definition, the consistency and stability of research results over time and across conditions. Types of reliability, test-retest reliability, consistency of results when the same test is repeated. Inter-rater reliability, agreement between different raters or observers. Internal consistency, consistency of items within a test or survey. Strategies for ensuring reliability, use standardized procedures for data collection. Train researchers to ensure consistent application of methods. Conduct reliability tests, e.g., Cronbach's alpha for internal consistency. Example, a company validates a new employee engagement survey by testing its reliability and validity before full implementation. Conclusion: overcoming challenges in business research requires careful attention to data privacy, data quality, and research validity. By addressing these issues proactively, researchers can ensure the integrity and usefulness of their findings. This chapter provides practical strategies for managing ethical concerns, dealing with incomplete or biased data, and ensuring the validity and reliability of research, enabling businesses to make informed and credible decisions. Part 6, Appendices and Resources. 40. The Appendices and Resources section provides additional tools, references, and templates to support your business statistics and research efforts. This section includes a glossary of terms, a sample research proposal template, recommended reading, statistical software, and templates for data analysis and reporting. 16. Appendix A, Glossary of Statistical and Research Terms. A comprehensive glossary to help you understand key statistical and research concepts. Confidence interval, a range of values within which a population parameter is estimated to lie, with a specified level of confidence. Hypothesis testing, a statistical method used to make decisions about a population based on sample data. Normal distribution, a bell-shaped distribution where most data points cluster around a mean. P-value, the probability of obtaining results as extreme as the observed results, assuming the null hypothesis is true. Regression analysis, a statistical method used to examine the relationship between a dependent variable and one or more independent variables. Sampling bias, a bias introduced when a sample is not representative of the population. Standard deviation, a measure of the dispersion or spread of a set of values. Validity, the extent to which a study measures what it claims to measure. 17. Appendix B, Sample Research Proposal Template. A template to help you structure and write a research proposal. Title, a concise and descriptive title for the research. Introduction, background information and context for the research problem. Research objectives, clear and specific goals of the research. Research questions/hypotheses, the questions or hypotheses the research aims to address. Literature review, a summary of existing research related to the topic. Methodology, detailed description of the research design, data collection methods, and analysis techniques. Timeline, a schedule outlining the key milestones and deadlines. Budget, an estimate of the costs associated with the research. References, a list of sources cited in the proposal. 4118. Appendix C, recommended reading and resources. A curated list of books, articles, and online resources to deepen your knowledge of business statistics and research. Books, The Art of Statistic by David Spiegelhalter. Naked Statistics by Charles Whelan. Research Methods for Business Students by Mark Saunders, Philip Lewis, and Adrian Thornhill. Websites and blogs, Khan Academy, www.khanacademy.org. StatTrek, www.stattrek.com. 538, www.538.com. Podcasts, Data Skeptic. Not so standard deviations. Online courses, Introduction to Statistics by Stanford University, Coursera. Business Statistics and Analysis by Rice University, Coursera. 19. Appendix D, List of statistical software and tools. A list of popular software and tools for statistical analysis and data visualization. Statistical software, SPSS, a comprehensive tool for statistical analysis. SAS, advanced analytics software for data management and predictive modeling. Stata, a versatile tool for data analysis and visualization. Programming languages, R, programming language for statistical computing and graphics. Python, a versatile language for data analysis and machine learning. Data visualization tools, Tableau, a powerful tool for creating interactive data visualizations. Power BI, a business analytics tool for visualizing and sharing insights. Matplotlib, a Python library for creating static, animated, and interactive visualizations. Machine learning libraries, scikit-learn, a Python library for machine learning. TensorFlow, an open-source library for machine learning and deep learning. 42. PyTorch, a machine learning library for applications like natural language processing. 20. Appendix E, Templates for data analysis and reporting. Templates to help you analyze data and present findings effectively. Data analysis template, data cleaning, steps for handling missing data, outliers, and inconsistencies. Descriptive statistics, summary statistics, mean, median, mode, standard deviation. Inferential statistics, hypothesis testing, confidence intervals, regression analysis. Report template, title page, title, author, date. Executive summary, a brief overview of the research objectives, methods, and key findings. Introduction, background and context of the research. Methodology, description of data collection and analysis methods. Results, presentation of findings with charts, graphs, and tables. Discussion, interpretation of results and their implications. Conclusion, summary of key insights and recommendations. References, list of sources cited in the report. Conclusion. The appendices and resources section provides practical tools and references to support your business statistics and research efforts. Whether you are writing a research proposal, analyzing data, or presenting findings, these resources will help you work more efficiently and effectively. This section is designed to complement the knowledge and skills covered in the previous chapters, enabling you to apply statistical and research methods with confidence. Conclusion. 43. As we reach the end of Mastering Business Statistics and Research Methodology, a step-by-step guide to data-driven decision-making, it's important to reflect on the journey we've taken together. From understanding the fundamentals of data and probability to exploring advanced techniques like multivariate analysis and time series forecasting, this book has provided a comprehensive roadmap for mastering business statistics and research methodology. The ability to analyze data and conduct research is no longer a niche skill, it is a necessity in today's competitive business landscape. Whether you are making strategic decisions, optimizing operations, or exploring new market opportunities, the tools and techniques covered in this book will empower you to make informed, data-driven choices. The real-world examples, case studies, and practical exercises included throughout the chapters have demonstrated how these concepts can be applied to solve actual business problems. However, mastering statistics and research is not a one-time achievement, it is a continuous process of learning and improvement. As new technologies, tools, and methodologies emerge, staying updated and adaptable is crucial. The final chapters of this book emphasized the importance of building a data-driven culture, overcoming challenges, and committing to lifelong learning. By embracing these principles, you can ensure that your skills remain relevant and impactful in an ever-changing world. As you move forward, remember that the true power of statistics and research lies in their ability to transform raw data into actionable insights. Whether you are a business professional, researcher, or student, the knowledge you've gained from this book will serve as a foundation for success in your career and beyond. Let this be the beginning of your journey toward becoming a confident, data-driven decision maker. Thank you for choosing this book as your guide. We hope it has inspired you to explore the endless possibilities of business statistics and research methodology and to apply these skills to create meaningful impact in your organization and industry. The future belongs to those who can harness the power of data. Go forth and make it yours. 44.